AI agents have a problem. They take in a request and then they work autonomously to achieve a goal. But in long horizon tasks, it can be tricky to keep the agent focused across all of the different steps that the agent needs to execute. Because you see, in a single agent architecture, you might well hit a few predictable failure modes, like, for example, context dilution. As the task grows, the signal of the original goal gets a bit lost in the noise of the intermediate steps. Or we might have problems with tool saturation. The more tools you give the agent access to, the harder the tool selection becomes, and the more chances there are to call the wrong tool or maybe just to pass invalid arguments. And there's also the lost in the middle phenomenon. Even if the right instruction is in the prompt, LLMs can underweight content buried in the middle of a long context window. So instead of one agent trying to be the planner and the implementer and the quality assurance all at once, there is a trend for agentic workflows to adopt hierarchical AI agents. Now, most hierarchical structures have 2 or 3 types of agent, and at the top here, this is considered to be the high level agent. This guy is the top dog. So there's just probably one agent up here, and it can process strategic plans, it can perform task decomposition, it can manage processes. It's all the big picture stuff. And then below that, we have the middle layer. These are additional agents, and these are called mid-level agents, and they report into the high-level agents. So they receive directives from the high-level agent, and then they process them. So they do things like, well, they have their own tasks, like implement plans and further decompose tasks and coordinate teams of low-level agents. Yeah, there's another layer here, low-level agents. So let's draw some low-level agents in here. And I think you can guess what they are going to do. They report in to the mid-level agent. And these guys are the doers, and they're specialized for narrow tasks. Perhaps they're trained on certain data, or they're given access to particular tools. So these low-level agents, they receive their directives from above, from the tier above here, and then they report back results as they go. Mid and high-level agents use the results from the low-level agents to inform the next steps of the process. And I suspect that this hierarchy looks rather familiar to you because it probably mirrors how things are organized at your work. So we might have at the top here executives, and these are kind of analogous to the high-level agent because they're setting the strategy. And then the strategy is decomposed into multiple projects. That's managed by product teams, or perhaps it's managed by a team of PMs, project managers. They're the mid-level agents. And then the actual work is performed by a series of specialists at the low-level agent level. They're reporting up through the hierarchy. You know, I've never really considered myself analogous to a low-level agent until right about now. Now, this structure works because it's, well, not exactly new thinking here. It applies a classic software engineering principle to the world of AI, separation of concerns. Now, in a monolithic agent, the model is constantly context switching between high-level reasoning, like what shall I do next, and then low-level execution, like which tool should I use to execute this task. But by kind of separating the work across a hierarchy, it overcomes a lot of limitations, and that includes limitations like solving context dilution. So instead of the entire conversation history being dumped into every prompt, a hierarchical system uses contextual packets, which is to say the high-level agent maintains the global state, but when it delegates a task to a lower level agent, it only sends a kind of a pruned relevant slice of that context. So if this agent's job is, let's say, just to format a JSON file, well, it probably doesn't need to know the initial 4,000 word strategy document. And that keeps the signal to noise ratio high, and it prevents the model from getting lost in the middle. And this hierarchy helps with tool saturation as well. So in IT, we generally follow the principle of less privilege, and this agentic hierarchy lets us do the same thing for AI through tool specialization. Low-level agents, these guys at the bottom, they only have access to specific tools. So if this was the security agent, it gets access to the vulnerability scanner tool, but it doesn't get access to the CI/CD pipeline tool. That's only for the DevOps agent, for this guy. So by limiting each agent to just a handful of tools, the agent isn't having to guess which tool to use. It's selecting from a narrow purpose-built toolbox. Now, another thing about the single agent architecture is you usually need to use the most expensive, fancy, high reasoning model you can get your hands on, because some tasks aren't going to need it. But for simpler tasks, incurring the inference costs of a big old frontier model can be a bit of a waste of compute. So in a hierarchy, you have a bit of model flexibility. You can fit different models to different tasks. So maybe the heavyweight frontier model, that's used as the high-level agent at the top here for all the complex planning and the task decomposition that this guy needs to do. But for some of the lower-level agents running more modular, self-contained tasks, they can run a much lighter weight model. There's a bunch of other advantages as well. This is all very modular, so each agent can be tested and updated and swapped out without really touching the rest of the system. It allows for parallelism, which is to say we can have multiple agents working on different parts of the problem all at the same time. And it also provides recursive feedback, a recursive feedback loop. So when a low-level agent finishes a task, it reports back to the mid-level or the high-level agent. And that can kind of act as a bit of a quality gate where the supervisor can monitor output and trigger a retry or just kind of pivot if the result appears to be an error. So this all sounds pretty good, but hierarchical AI agents do have some real limitations to be aware of as well. And the first one of those is that task decomposition, it's just kind of really hard. I've performed the project manager role enough myself to know that. So the entire system here, it hinges on the high-level agent's ability to break what is quite likely a pretty complex goal into the right subtasks and then to route them through to the right specialists. And if it decomposes poorly, so maybe it misses a step or maybe it sequences things in the wrong order, well then everything downstream is going to inherit that mistake. It's garbage in, garbage out. That garbage is flowing through 3 layers of agents. So the high-level agent needs to be good at planning, and current LLMs are inconsistent at planning. They can sometimes miss dependencies or they can underestimate complexity. Well, the thing I see the most is that they over-decompose simple tasks into unnecessary steps. So that's one thing to be concerned about. There's also orchestration overhead. So this is stuff like designing the state management and then defining the handoff logic between the agents, building retry loops when things go wrong. Unlike a single agent, this requires architecting an entire system. And if the logic that governs how agents talk to each other is just a bit brittle, then the whole system can fall into a rather unfortunate recursive loop. That's where agents just kind of keep passing errors back and forth between each other until they hit their token limit. Now, there's also the potential for the good old telephone game effect, like how at work a manager issues an instruction that gets filtered through a couple of colleagues, and then the person who's actually doing the work gets told something subtly but meaningfully different from what the manager was asking for in the first place. Well, the same thing can happen with agents. If task decomposition is slightly off, or if the wrong bit of context gets pruned when sending the data packet all the way down the line here, well, the specialized agent can end up perfectly executing the wrong task. So yes, hierarchical AI agents can keep your agent from getting lost in the middle, but they can still get lost in the org chart. So the trick is to treat the hierarchy like any other system you'd put into production. You need to design the handoffs, you need to validate the work, and just like in real life, never assume that the top dog always wrote a perfect plan.